Hello. Today we are going to discuss about the different applications of the nano coating. If you remember, in our last lecture we have discussed about the various types of advanced coating practices which we are going to do for the modifications of the surface of our substrate so that we can get some better properties. So in this particular lecture actually we are going to use those kind of materials for different applications. So before going to start, let us give a glimpse of that nano coatings, that what we are doing and what we are going to be get. So first is that nano coatings are one of the most important topics within the range of the nanotechnology. This sentence we are talking several times. So actually the main motto of this particular lecture is that whatever the nano modifications or maybe the nano composites modifications we have done, how we are going to use those materials for our normal life or maybe day to day life or for the industrial purpose or maybe some other applications like biomedicals or maybe some kind of industrial applications. So here the nanoscale engineering of surface and layers helps to achieve vast range of functionalities and new physical effects. As I told in my last lecture that when we are going to modify those nano composites, of course there is certain reason behind that. Suppose I am having some materials which is showing some conducting nature, but in I have to use that materials for some other purpose where I need that material into the non-conductive mode. So what I am doing, I am trying to put certain kind of coatings of some kind of non-conducting materials so that our substrate or maybe the materials can change from conductive to non-conductive one. Same thing we are using for those materials for the biomedical implants. Suppose I am making any kind of metal composites for any joint replacement, but if I put directly put that material into our body, maybe our body will not accept those materials. So for that purpose I have to attach some kind of materials which can be compatible with our bloodstream or maybe blood vessels, and our cells can grow on it so that we can get the exact purpose of that particular implants. So here the nano engineering of surface, that means when we are doing the coatings of these nano materials, it is having a vast applications, that same material can be used for several applications at a time. Several techniques have been proposed for the preparation of nano composite coatings. So these different types of advanced nano composite coatings already we have discussed in our last several lectures, that how we are going to do like PVD, CVD, ion sputtering, ion depositions, ion implantations like this, and not only that how we are going to modify by the sol gel technique and some electro deposition techniques. So there are so many n number of applications, n number of synthesis process we have already discussed by which we are trying to modify our materials. Among them reactive magneton sputtering is most commonly used. So this is also one kind of latest technology by which we are changing our surface of that particular materials so that we can get some advanced properties. Nano composite coating can be tailored to offer superior hardness above the maximum given by the rule of mixture. Ultra hard materials are materials with hardness greater than 80 gigapascal. So in that particular case what we are trying to say, that not only that we are only changing its appearances, we are changing its outside lucrativeness, but still we are trying to change its physical properties, like we are changing its mechanical properties in terms of tensile strength, elongation at break. Not only that, sometimes we are changing its hardness, sometimes we are changing its optical properties, sometimes we are changing its electrical properties, sometimes we are changing its some kind of morphology kind of thing. So there are n number of properties we can change by doing this kind of nano composites coating. Detailed theories have been developed and extensive experiments carried out with the aim of optimizing the hardness of nano composite coating for many industrial applications. So we are trying to modify this kind of nano composites for our machine tool purposes, where we are using this kind of nano composites for cutting tool changing or maybe the preparation of the cutting tool. Sometimes we are using this kind of materials for the indentation method, sometimes we are using this method for the scratching purpose. So there are n number of applications are available in the point of mechanical engineering side. And also besides in designing nanocomposite coating, several factors and applications requirement must be considered. So when we are improving these properties, simultaneously we have to keep in mind that when we are increasing some properties may decrease also. Suppose I want to increase the corrosion properties of that particular material, maybe wear resistance property can be decreased at that certain time. So what we have to keep in mind, that what is the main motto of our coating techniques, why we are doing this coating, which property I need at most. So depending upon that property, maybe rest property is not required to me, so that time we can decrease those properties or maybe we can eliminate those properties. So here first we are going to discuss that what are the coating properties actually we are getting. So highly effective dart repellent or maybe the non-stick coatings resembling glass, ceramic or Teflon. Nowadays we are using several chemical utensils. So in that particular utensils, what we want, when we are keeping that utensils in our lab, maybe some dust or maybe the dart can come, they can stick with the glass or maybe that ceramic bowls, maybe the micro pipettes or any kind of chemical utensils. So what our main motto is that we are trying to introduce some kind of material when we are putting onto the glass substrate, so that the dust or dart particle will not be stick with those chemical instruments, and also we no need to clean it several times. Also it will reduce the cost of that total experiment procedure. Not only that, it will reduce the usage time because we no need to clean several times, also it will reduce the cost. Next is that hydrophilic, conductive, color, transparent or decorative and corrosion proof coatings. So sometimes we are making our nanocomposites from hydrophobic to hydrophilic, just coating of some materials which is hydrophilic in nature. Sometimes we are making, as I told already, sometimes we are using some kind of conducting materials coatings onto the non-conductive material, so that that material can be used as a conductive material. Sometimes we are doing the colored for ornamental purpose, we are doing some decoration or maybe some kind of aesthetic view, some kind of interior designs or maybe some kind of interior products which we are using in our day to day life. In that particular case we can do some kind of coatings so that it can be lucrative, and not only that, it can be corrosion proof, because nowadays the biggest problem is that corrosion. Suppose I am keeping some materials in the environment for a longer time, what will happen, it will try to absorb the water molecules or maybe the moistures or maybe some kind of toxic gas from the environment itself, and the reaction will be going on. Due to that, either maybe its paint will go off or maybe rusting can be done. So we have to put certain kind of material on our substrate so that it will be corrosion proof material. Next, high adhesions of coatings chemical bond with the workpiece surface. Not only that, when we are putting the coating, our main motto is that the shelf life of that coating should be increased, but when we are doing some kind of coatings onto our base materials, we have to check whether that coating materials is compatible with our base materials or not. If it is not compatible, what will happen, after certain time just simply it will come out. So there should be attachment in between the coating materials and the base material so that it can stick properly. Next, high chemical and temperature resistance, that is also another motto. Suppose today I am preparing some materials which I am using in India. So India generally the temperature goes around 40 to 42 degrees centigrade or maybe 45 degrees centigrade in the summer. If we keep that material into the desert, maybe temperature goes around 60 degrees centigrade. Suppose same material if I want to use in USA, so in the winter time temperature goes around minus 10 degree, 15 degree, 20 degrees centigrade, like that. So I have to prepare a material which can work in USA in the minus temperature. If I keep that material into the maybe south pole, the temperature goes around minus 100 degrees centigrade. So my material ranging should be from minus 100 degrees centigrade to the maybe the higher side, maybe 200 degree or 300 degrees centigrade. Sometimes I can use that material for the oven purpose or maybe the furnace purpose, which temperature goes around 800 degree, 900 degrees centigrade. So my coating material should have that capability that it can withstand the temperature ranging from minus 100 degree centigrade to 800 degree centigrade. Next is that diffusion barrier for certain metal ions. Next, can be cleaned with very little effort. That is also the another issue. Suppose I am using certain kind of coating materials and maybe some dirt or dust has come, but if it will stick rigidly with the coating materials, then it is very difficult to really release or maybe that clean those dart materials. So, our coating material should be like that it will not absorb the dust or maybe the moisture from the environment itself. Then a nanocomposite coating, strictly speaking, is not a coating, but rather permanent chemical modification of the workpiece surface with a gradient material. Yes, of course, the thing is that our main motto is to save our substrate material from the environment or from any kind of attack. So, the thing is that not only we are doing the coating, rather we are changing its chemical structure, so that that material can be used several times for several applications in near future. Next, we are going to discuss about some conventional coating technologies for automotive and the aerospace industry. Nowadays, if you remember, when in the earlier days when we are preparing some car and all these things, that is made by some kind of aluminum. Nowadays, the flight, actually also previously it was made by some kind of aluminum composites, but nowadays the flight or maybe the car, that is made by some kind of polymers like ABS polymers. Flight is making by the Kevlar polymer, which is more harder than the steel. So, though when you are using this kind of polymers, though its processing is little bit difficult, but still they are very light in weight and also the cost is cheaper, and not only that, they are giving maybe 2.5 times or maybe 3 times better than the steel in terms of mechanical strength. So, when we are talking nowadays, so we are trying to make this kind of polymers or maybe the coatings onto the surface, so that we can use these materials for the automotive parts or maybe the aerospace parts. If you remember that when we are keeping these cars or maybe the automobiles or maybe the aerospace like a flight or maybe some kind of missiles, we are keeping it into the normal environment, so that it is getting the sunlight. When it is going to the top, its temperature goes around -50 degree to 60 degree centigrade, again certainly it comes to the room temperature. So, the applications wise the temperature range is bigger. So, we have to keep these coatings in such a manner, so that it can act into the room temperature, into the minus temperature, and also into the higher plus temperature. So, how we are doing? First, we are doing by the chemical conversions coating. So, what is the chemical conversions coating? So, simple, by doing this kind of things we are going to do the chemical conversions coating. So, first we are putting some paint on our metals or maybe that our substrate. So, that paint, when we are putting, they are trying to change its properties and then they are sticking with these metals, so that after conversion this paint will remain unaltered for a longer time. So, for most metal and alloys, corrosion reactions are slowly by a naturally occurring passive thin oxide layer formed at the surface in a specific environment, because these corrosion reactions are the most irritating properties for us. Suppose I am keeping a material for a longer time, so it will slowly absorb the moisture or maybe the some kind of acid or maybe the some kind of base from the environment itself, and they will react each other. When there will be a reaction, they will make certain kind of oxide films or maybe the sulfide films or maybe the nitride films onto it. So, what will happen? We will lose our materials as well as we will lose our weight of that particular material. So, the main motto of this study is that we are trying to put certain kind of coating materials which will just make a barrier in between the environment and in between our substrate. Next, artificial passivation films which improve the corrosion resistance have been produced by various process, because oxides are susceptible to mechanical damage. Localized corrosion will occur at damage site. So, simple that we are making certain kind of material which will give us a corrosion resistant property, so that environmental will not directly come into the contact with the substrate itself. Next, aluminum alloys are widely used in the automotive and aerospace industries. Already I have discussed. Naturally occurring aluminum oxide with associated flaws of defects generally offers corrosion resistance for aluminum surface. So, sometimes what we are doing, we are adding certain kind of materials like some kind of rare earth materials like neodymium, chromium, or maybe some kind of anti-corrosive materials with the aluminum. Then we are preparing the aluminum alloy. Then we are doing that material coating onto the aluminum, so that what will happen, because if I keep only aluminum, so it will just absorb the oxygen and it will form the alumina oxide. So, it will make a oxide layer onto it. So, just to stop that one, we are adding some kind of nanofillers into the aluminum itself, so that it can act as a self healing. So, if there is some virgin aluminum will come, then automatically they will do the reaction and they will make the protective coating onto it. Next is that organic and inorganic coatings. So, like epoxy coatings and inorganic zinc rich coatings have been used to protect ships and marine structures from the corrosions. Yes, if you remember, I had talked about the anti-fouling. So, what is that? When we are making any kind of submarines, or maybe we are making any kind of ships, when it is going inside the water, in the water there are several creatures or maybe the animals are present. So, they are exhalting certain kind of their waste product, which is reacting with that body of that submarines or maybe the ships. So, what is happening? Some kind of algae formations is taking place, some kind of bacteria is taking place, or maybe some kind of rusting is taking place. Just to stop all these things, we are putting certain kind of epoxy coatings or maybe some kind of zinc rich coatings, because they are acting as an anti corrosion element onto it. So, by which that the material will remain same inside the water also. Next, research and development in binder and pigments has improved the durability of coatings for other severe environments. Sometimes we are putting certain kind of binders, because we have seen that several times that coating material may not stick with the substrate properly. So, that time we are using certain kind of binder or maybe pigments or dye. What is that? Actually, they are acting as an additives. So, what they will do? They will make a bonding in between your coating materials and in between your substrate, so that they can stick together. The most common coating systems were silicon modified polymers and fluorine modified polymers. So, nowadays people are trying to use the products by the polymer, because that is having less weight, that is cheaper than the metals, and that is the easy process. So, what we are doing? We are trying to add some kind of silicon element inside this polymer, or maybe that some kind of fluorine inside this polymer, so that any kind of oxidations, maybe corrosions or maybe anti-wear properties can be achieved. Automotive clear coatings, architectural paints and some general industry coatings are used because of their superior durability. When you are talking about the automotive clear coatings, generally we are putting it into the glass itself. So, previously what happened, when we are using our car and when we are going into some rainy seasons, the water is coming, the water droplet is sticking with our window shield or maybe that front window or maybe that front glass. So, nowadays we are trying to put certain kind of coating onto the glass itself, so that water bubble will come, but it will not stick with the glass itself, simply it will go. That means we are putting certain kind of hydrophobic materials onto our glass, so that water particle will not stop onto it. Not only that, when you are using this kind of architectural paints, previously what happened, we are trying to put certain kind of paints, but during the summer, during the intense heat, the paints is having some crack or maybe some rainy seasons, that water particles go through inside and it can damage our structure, concrete structure. But nowadays we are trying to put certain kind of paint, if there is certain kind of crack, so automatically they will come over, they will make the new reactions and automatically they will stop this kind of cracks over there. Next is that such coatings are highly durable, because the life of that particular materials is increasing day to day, and stain resistance. So, there will not be any stress, so that the strain will be almost 0 due to the resistance of their cross linking bonds to water, chemicals and ultraviolet radiations. So, as I told already, if there is any breakage in between the polymer chains, what they will do? Just simple, they will absorb the maybe the sunlight or maybe the water or maybe some other molecules, and the chemical reaction will be taking place in between the coating materials, and once again they will join together, so that they will make the continuous coating onto the substrate itself. So, here it is an example, like for organic matrices, generally we are using certain kind of epoxy materials, acrylic melamine or maybe the urethane. Urethane is nothing but a one kind of polymer or maybe that rubber generally we are using. When we are talking about the sol gel networks, we are using the silica, titania and some kind of physical hybrids material. So, here the thing is that this is all the examples of that substrate, and onto that we are doing the hybrid coating. Sometimes what happen, if we see only a single material onto that, if we put some only one single material onto our substrate, maybe that material is not sufficient for the coating purposes. So, what we are doing, we are try to add 3 to 4 different types of nanomaterials or maybe the different types of materials to make the coating materials. So, that is why we are sometimes it is called is at say hybrid coating. Then when we are talking about the nanoparticles, sometimes we are using the silicon dioxide, then alpha phase alumina, silicon carbide, ITO, CNT carbon nanotubes, titanium dioxide surface functionalized. So not only that, in these days we are not satisfying for a single material, we are trying to do the modification of these nanofillers, and by several routes, several approaches we are trying these nanofillers, and we are trying to develop a new materials which will be more durable, having good wear resistant, corrosion resistant, and which can remain same for a longer time. Next we are going to discuss about the thermal sprayed coating. So in the thermal spraying is a mature technology for forming the hard coating. So in the last class also we have discussed about the thermal spraying. So several processing routes can be employed depending on the nature of substrate and performance required of the coating, including plasma spraying, high velocity oxy fuel, HVOF spraying, detonation flame spraying, and the flame spraying. If you remember, in my last lecture I have discussed about all these kind of techniques. Here nothing, that whatever the nanoparticles we are using, simple, we are heating those nanoparticles, then I am having some carrier gas which is taking that nanoparticles from the gun to the substrate itself. Then that heated nanoparticles is simply stick onto the surface itself, and then gun can rotate throughout the material, or maybe that gun may be in the static positions and your material can rotate into the different angle and different actions, so that you can get a uniform coating all over around. So the HVOF method is based on a combustion process for heating and accelerating of the powder coating material to high velocities. So we are giving a high velocity to these nanoparticles, so that its kinetic energy directly giving a thrust onto your surface of, or maybe the substrate, so that due to due to its high kinetic energy, that nanoparticle can stick onto the surface itself. Then combustion of fuel gas such as acetylene, propane, propylene, and hydrogen is premixed with the oxygen, so that the heat generation of that particular things will be more, because sometimes we are using certain kind of nanoparticles whose melting temperature is too high. So that time we need to ignite those nanoparticles. Then for that particular purpose, maybe we have to put certain kind of combustible liquids which can heat it up at that particular temperature, and then that nanoparticles can be melted. So here this is the things actually what we are going to do. So here we are having that substrate, then simply we are putting the spraying onto that substrate itself. This is the FESM image where you can see that we are having that substrate in white in color, and then little bit grayish color, it is showing the how much coating thickness we have done by this thermal spray processing. Here also the same thing, this is our substrate. Then here I told that if the temperature of that nanoparticle will not go up to its melting point, maybe some kind of unmelted particles will be included into that. Then we are some kind of, if there is some pores and cracks, the oxide formation will be taking place, and then we can see some kind of pores or cracks. So what we are trying to do, we are trying to make that melting of the nanoparticles in a certain temperature, so there should not be any unmelted particles, or maybe there should not be any cracks, or maybe the oxide formations will be there. So these all are the added advantage for this type of coatings. Next we are trying to do the self cleaning coatings. So as I told already, we are trying to put certain kind of materials on the glass, or maybe our window glass, or maybe somewhere where we need that water should not be stopped, or maybe where water should not form any kind of droplet over that. So in that particular purpose, what we are trying to do here, that coating are needed to improve comfort by simplifying de-icing in winter and reducing heat transfer during the summer. So what we are trying to do, because when we are using this glass, in the winter time the glass is going into the minus temperature, in the summer time the same glass is going to the plus temperature. So there is a very much heat changing from winter to summer. So what we are trying to do, we are trying to put certain coatings that the temperature of the glass should not go into the minus temperature, or maybe that the glass temperature should not go into the plus temperature. If it will go on for several times, the residual stress will be generated inside the glass, through that maybe the glass can break. Simply I am giving you one examples. If you put certain, whatever the glass or maybe that cup we are using in our day to day life, if that particular glass or maybe that particular cup material is not good, then what happens, certainly if you put the hot water inside it, simply it will break. So that is the phenomena actually same thing is going on over here. So just to stop this one, we are trying to put certain kind of coatings onto that, so that it can withstand that temperature. Also also that temperature, that hot temperature or maybe the extreme cold temperature will not reach to the glass, so that it will not break. Nowadays you can remember that we are trying to use certain kind of melamine materials which is having a very high heat resistant capability for this particular purpose. So here also another thing is that highly scratch resistant surface coatings are also needed to protect the soft PC, and an additional UV blocker has to be integrated in order to prevent the degradations. Here highly scratch resistance and UV blocker also are the main important factor, because when we are driving our car, maybe sunlight can directly come from the front. So if the front glass does not have any UV blocker, that UV will directly come to our body, it will affect our eyes or maybe our health or maybe our skin. So we have to use certain kind of coating materials which will just stop or maybe the resist that UV from our front side, so that any kind of UV light can directly come to our body. Not only that, another most important thing is that highly scratch resistance, because when we are driving our car, the dust particle is mixed with the air. So when we are traveling in a high speed, that dust particle is continuously hitting on our glass surface. If our glass surface is not the scratch proof, they will make certain kind of scratch. Another very good example is that in our spectacle. So if our spectacle does not have any coating, so continuously wearing these spectacles and going to the outside environment, so that simply the dust particle it is coming, it is stagnant on our glass surface, and not only that, it is making certain kind of scratch. So nowadays we are using certain kind of scratch resistant materials onto the glass, onto the specs, so that the dust particle will not make any kind of scratch or maybe that rubbing actions onto the surface. Also it is a challenge to realize such complex coatings on industrial scale at reasonable cost. Yes, of course, whatever the research we are going to do, all the research now into the laboratory purposes, because when you are trying to do this kind of research for a larger scale or maybe for the industrial site, so that time the cost is increasing, because for the industrial purpose the equipment, the machines, the total utensils is in a bigger size. So what we are trying to do, we have to modify these materials, but simultaneously we have to reduce the cost. So that is the biggest challenge for the scientists, that just not keep our research into the laboratory purpose, we have to expand our research to the industrial purpose also. So here the thing is that what I have told you, that we are having some kind of bare surface, then we are having the surface contaminants. So when the water droplet is coming, simply it is sticking with the bare surface. But now what we are trying to do, we are trying to do some kind of surface contaminants onto that. So we are trying to do some kind of nano coatings. So when we are trying to put some kind of nano coatings, it is generated certain kind of surface contaminants or maybe some kind of properties, so that water droplet will not stick with this material directly. So after some time the water droplets will go out. Next thing is that electrochromic coatings with a variable transmission will replace mechanical blinds in sunroofs in the future, and also in side and rear windows. That is also one kind of latest technology we are trying to develop for our automotive purpose. Next, the traditional concept of easy to clean glass will be replaced by a self cleaning concept by integrating sensors or semi transparent displays into the windscreen. Of course, we are trying to put certain kind of sensors, then when the dirt or maybe dust or maybe the water particle will directly come into the contact with the glass, then automatically its cleaning will be done. So it will be good to use any kind of self cleaning properties. So that is also one kind of latest technology what we are going to use in our research. Next is that the powder coating. So if you remember that powder coating is nothing but the same kind of nanoparticles powder, just we are spraying onto that our substrate. So due to that the powder will stick, but there is certain kind of principles, either that powder will be heated up or maybe that substrate will be heated up, then only that powder can easily stick onto the substrate itself. So the main objective of powder coating technology is to provide coatings that are at least equal in performance to the liquid coatings without sacrificing ease of applications or environmental advantage. So if we try to make certain kind of paints, so either we have to add certain kind of acids or maybe some kind of toxic materials, but if we directly use this powder and directly put onto the substrate, so from the environmental point of view it is more safe and it is more clean. Next, advantage in powder coating technology aimed at improving the material durability and performance while using the thinner films. So also that powder coating is increasing its life. Next, improvements in powder coatings tend to be aimed at providing cost effective repellents, because the replacement of this liquid painting is biggest problem is that if we want to do the liquid painting, either I have to hire one labor, then I have to use some kind of brush or maybe some kind of gun, and there are several things. I have to purchase the thinner, then that painting I have to do, or maybe it is needs some time to dry, in between that something happen, then again I have to do it twice. So there are lots of problems can occur at that particular time. But if we do directly powder, so powder will simply heat onto the substrate itself, so that there it is easy drying, so that easily it can be replaced by the liquid replaced the liquid painting. All of these improvements come at a cost and depend on parts of finishing process. Also the finishing process of this case is very easy. Next is that transparent coating. Transparent functional coatings have been produced by a modified physical vapor synthesis process using nanocrystalline particles. So here the main thing is that we are using some kind of transparent coatings. From this figure you can understand that here we are putting some kind of transparent coatings. What are the main advantage of this coating? This will reflect the sunlight, so that sunlight will not go inside. Not only that, this will reflect the UV, so that it is acting as a UV blocker. Not only that, it can not absorb any water particles, so that water will not stick with that glass or maybe that with that metals, and there are so many advantages are there. Their applications include coating to protect against UV and infrared radiations, transparent wear resistant coatings, and the conductive anti-static coatings. To form the radiation resistant coatings, nano size zinc oxide, titanium dioxide, antimony tin oxide or indium tin oxide are incorporated into commercial film polymers to form clear coats. Nano aluminum oxide is incorporated into transparent clear coatings to increase their hardness, scratch resistance and wear resistance. So not only that they are giving you the transparency, they are trying to improve the other properties like the scratch resistant, wear resistance and any kind of hardness properties. Transparent coatings with nano alumina offer improved abrasion resistance for transparent plastics, highly polished metals, wood and laminate materials. Next we are trying to discuss about the thermal barrier coatings. So thermal barrier coatings, generally we are using those materials which materials we are using into the higher temperature, like turbine blades or maybe some kind of engine parts or maybe some kind of missiles, where we are trying to use this kind of materials in a high heat temperature zone. So the improvement in gas turbine engine is related to turbine inlet temperature, structural design, airfoil cooling, high strength at a temperature alloys, protective coating systems. So from this particular system you can understand that we are using these materials for a higher temperature, at a higher temperature. Then what we are trying to do, we are using some kind of zirconia based ceramics were considered for the TBC applications, thermal barrier coating applications, due to their low thermal conductivities, high melting points and thermal expansion coefficients. So another issue is that suppose I am trying to use certain kind of metals, when it will get the temperature, automatically the elongation will be taking place. But sometimes when it will you are using these materials into the room temperature or maybe the minus temperature, it will be contracted. So there will be expansion and contraction. Due to that, the total machine or maybe that equipment dimension and shape can be changed. Not only that, we can get some kind of error from that particular equipment. So what we are trying to do, we are using certain kind of zirconia based ceramics which will remain same, which is having very low thermal coefficient and thermal conductivity is also very low. In that particular case, it will not change its shape and size at that particular temperature. Zirconia yttria TBCs are best up to 1400 degrees centigrade when deposited on a metallic bond coat. TBCs can be produced by thermal spray and electron beam physical vapor depositions. However, the latter is more durable and thus is recommended for use on turbine blades and vanes in aircraft engine. So generally we are using these electron beam physical vapor depositions that just to make a thermal barrier coating onto the turbine blades or maybe that aerospace engine parts, so that it can withstand with the high temperature. Here this is an example. So the thing is that what we are doing, we are trying to do the thermal barrier coating onto the turbine blade. So this is the turbine blade. When we are trying to take a small FSM picture on the surface of that, we can see that we are using this kind of materials over there. So first in that case we are having some bond coat of 100 micrometer, then we are using some zirconia oxide top coat from 100 to 400 micrometer, and then also we are using some kind of air film, so which will act as a cooling material. So that means when the temperature will go up, that automatically that cooling film will absorb the temperature, so that the maximum temperature will not go inside the blade, so that it will not change its shape and size. So these all are the different types of applications where we are using this type of nano coatings. Next is the applications for the packaging applications in food and pharmaceutical industries. Yes, of course, that is also a vital and most important parameter for us, because when you are using some kind of liquid products like any kind of soft drinks, any kind of milks, any kind of products which is wrapped by some kind of polymers or maybe the plastics, every time we are talking about the purity of that particular materials, but never we are talking about the wrapping materials or maybe about the bottles. So nowadays that is the biggest problem for us, because we are talking about the food is not good, or maybe food odor is not good and taste is not good, but nobody is talking about that bottles, that which plastics that bottle has been made, but which polymer that we are wrapping those bread or maybe some kind of, say like chocolates or maybe anything else. So when you are talking about this kind of materials, that plastic should be biomedical good enough and the degradable plastic, so that will not make any kind of toxic gases or maybe any kind of toxic reactions that which directly will come onto the food or maybe the liquids. So only we are talking every time about the aesthetic views of the bottles or maybe that stickers or maybe the labels, but never we talk about that by which material that bottle has been made. So here the plastic containers are used in the food and beverage industry because they are lightweight, unbreakable and resealable. So previously that Coca-Cola can was made by some kind of aluminum foil, but nowadays people are trying to replace those one and they are making this foil by some kind of polymers or maybe the plastics, due to its less weight, and also the cost of the container will be reduced. Next, PET, polyether tetryl bottles have also almost replaced glass bottles and metals can as the most common packaging for liquids. Nowadays we are using the plastic bottles, because previously we are using that glass bottles for the milk preservations, but if the glass bottle will fall, it will break. But nowadays these PET bottles are flexible, if we put it if it fall it from our hand also, it will not break properly. Nano coatings such as nano composite films offer solutions to many challenges faced by the food packaging industry in relation to consumer health. For example, the unique properties of DLC, including its chemical inertness and impermeability, open up new applications in the food, beverage and biomedical industries. However, other research should be done to reduce the surface defects in DLC coatings from which corrosion is usually initiated. So there are so many initiatives has been taken just to make the bottle from the toxic free, and not only that, it should be less weight and it should be less cost. Next thing we are going to discuss about the coatings for the electronics and sensor industry. So nowadays this is also the vital parameter, because if we remember that this kind of techniques is very good for our defense purposes. Suppose I am giving you one example. So when we are using that submarines, that certainly the submarines is going into the deep sea, right. So in the deep sea maybe some kind of toxic gases has been trapped inside. So what happened, if you remember also last 2 to 3 years ago, or maybe that last year, or maybe the last month also, the same thing happened to the submarines in Indian Navy, that when the crew is going at that particular point, due to some kind of trapped gas, they are dying. So what we are trying to do, we are trying to make some kind of sensor materials which can detect easily that what is the trapped gas actually present over there. So just getting the alarm, they can be cautious so that they will not reach. First they will remove those trapped gases and they can easily go, and by this way we can save our crew life. So here also the same thing we are going to do. The extreme stress and temperatures in combustors and turbines used in automobile and aerospace vehicles leads to severe thermal and thermomechanical damage which shortens the lives of the engines. Suppose we can detect the heat at that particular point, that how much heat is originating at that particular engine points, so that we have to reduce the heat. If we make some kind of sensors, but that sensor should be withstand that temperature. So here we have to make some kind of sensors which can detect that high heat and which can tell us that you have to reduce that in temperature at that particular point, so that we can reduce our engine temperature. Due to the application of protective coatings and advanced materials such as ceramic matrix composites in aircraft engines, traditional wet strain gauges and thermocouples cannot be attached to the components via conventional spot welding techniques. Nowadays we are trying to introduce certain kind of sensors which we can simply stick onto that surface, or maybe simple we can put at the point where the temperature actually will be originating. So it is not about only the thermal, it is about anywhere we can put this kind of sensors. So nowadays sensor and actuators are most widely used in our day to day life. Next, reliable but non-intrusive sensors that can provide both temperature and strain informations are urgently needed to measure and model such damage. Here we have given certain kind of examples of these sensors. Sensors based on nickel chrome and palladium chrome thin films have been successfully deposited onto nickel based superalloy substrate, showed a good strain sensitivity at high temperature. So if at the high temperature, if our engine parts or maybe body get damaged, or maybe some kind of stress or strain can be generated, simply this kind of sensor can measure that what is going on inside, and we have to reduce the temperature. So not only that, from the temperature point of view they are going to reduce, they are trying to reduce its stress and strain, not only that with the temperature itself. Next is that some kind of paints and enamel industry also we are trying to use this kind of nano coatings. So unique features of nanoscale coatings erased barriers between the chemistry, physics and biology. Yes, previously we are talking about the chemistry, we are talking about the physics, we are talking about the biology. Nowadays these all subjects became they have formed a intra chain in between that. So we are talking about the nanotechnology. Nanotechnology combines both physics, both chemistry, both biology, mechanical, metallurgical, all fields together. So it is a one kind of intra type of department. So when we are talking about the nanotechnology, when we are talking the applications, it based on the physics rule, it is based on the chemical rules, it is based on the biological rules. So all together can make this nanotechnology more better. So coating synthesized by nanotechnology showed unique optical, mechanical and chemical properties. Hybrid polymers of organic polymers and organically modified inorganic silicates have great potential for future coating systems. Such combinations offer special advantages such as chemical stability and scratch resistance due to the inorganic networks and high elasticity to the organic polymers. So as I told already, if you remember or if you watch the television, you can find that when they are giving some kind of advertisement about the paint, they are talking that some kind of polymer is attached with the paint. So that means when we are doing the paint from to the outside of our home or maybe the house, so what it is going, it is in direct sunlight, but it will reflect that sunlight, so that temperature will not go inside, it will not absorb any kind of moisture, or maybe it will not allow the water droplet or maybe that rain to our wall. So that is the all the added advantage to that paint industry. Hybrid polymers have also shown some good additions to glass, which will provide new opportunities for functional glass deposition techniques, because addition of the glass is very poor. If anything we are putting onto the glass surface, after certain time it will come out. So nowadays people are trying to make certain kind of materials which can easily stick onto the glass substrate, so that we can do the functional glass depositions. Next, we are trying to use this kind of materials for the biomedical implants industry. Already I have told you that we are trying to make certain kind of materials which we can use for some kind of joint replacement processes. Initially we are using some kind of metals, but the biggest problem in that metals is that after certain time, with the reaction with the bloods, the metal weight is getting decreased. So we are trying to use this kind of metals which will be anti corrosion proof, and not only that, which will not react with the blood vessels and simply cells can grow onto that. So for these purposes we are trying to replace this replacement by this kind of hybrid composites. So nowadays we are doing that joint replacement like hip joint, like ankle joint, like elbow joint. So several applications we are trying to use this kind of materials. Not only that, we are using these materials for the stent purpose. So when we are doing that bypass surgery, we are putting certain kind of stents. So that stents is also made by this kind of material. So what type of material generally we are doing? Hydroxyapatite is a bioactive material because its chemical structure is close to that natural bone. So simply we have developed a one kind of material whose property is almost equal as a bone. So when you are trying to make this kind of materials and we are incorporating those materials into the human body, simple the human body will accept those materials because that material properties is equal to the bone structure. Next, titanium and some of its alloys such as titanium 6 aluminum 4B, this is a one kind of aluminum composites are widely used as orthopedic and dental implant materials due to their low elastic modulus, good biocompatibility and corrosion durability. HA hydroxyapatite coatings are promising because they can exploit the biocompatibility and bone bonding properties of the ceramic while utilizing the mechanical properties of substrates such as titanium 6 aluminum 4 vanadium and other biocompatible alloys. Nowadays we are using certain kind of lenses which we are putting into our eyes, that is also made by some kind of polymer. That polymer is known as the PMMA, polymethyl methacrylate. So that is also some good compatibility, that is having some biocompatible because we are keeping that lenses for a longer time in our eyes, that is not reacting with our eyes water or maybe that eyeballs, and we can use that materials for a long time. Not only that, they are too soft and flexible also. Previously we are using certain kind of glass lenses. When we are putting those glass lenses in our eyes, always we have to put certain kind of spectacles, otherwise what will happen, maybe some heat or maybe some kind of load directly can come to our eyeballs, maybe that glass can break and it can damage our eyes. So whatever we are lenses nowadays we are using, that is totally scratch free, that is totally corrosion free, and that is totally flexible. So we don't need any extra spectacle over there. So simply we can wear this kind of lens into our eyes and we will be safe. Next, in summary, so here actually in this particular topic we have discussed several types of applications about the nano composites, but these all are very few. There are n number of applications, but due to the time constraint we have discussed a very few over here. So in this particular lecture we have discussed about the applications of nano coatings and accordingly in which field these nano coatings can be applied. Coatings properties were also discussed. The application of nano coatings can be been extended in the field of conventional materials used aerospace industries. The use of nano coatings has also been illustrated and their focused applications in the field of electronic industries as sensors. The use of nano coatings in biomedical implants has also been briefly shown. So these all are the technology is very few. There are n number of applications where we are using this kind of nano composites coating. Thank you.